Okay, so welcome everyone. This is the first lecture of programming in Python, a course, a fast-paced course for Python exercises and practice in Python. My name is Judith Ács. I work at the Hungarian Research Institute, and I'm a guest lecturer at TU Vienna for this lecture. The first time we'll start with an introduction to the Python language. The goal of this course is that you reach an intermediate level in Python, starting from a basic programming background. So I have to emphasize that this is not a beginner programming course. We expect some programming background, but it might not be Python. So we'll go over all the basics of the Python language, and we'll cover some advanced topics as well. Our goal is that you can both read and write Python code, which is very much necessary for machine learning or any kind of data science. You not just writing, but you have to be able to read third-party source code. And we will include lots of practice as well. The afternoon sessions are actually 3 hours long, and you will have plenty of time to practice what you learn here. We do have some prerequisites, so we'll assume that you learned some programming, preferably an object-oriented language. You are familiar with variables, types, functions, and the basics of I/O handling. And it's good if you know some object-oriented programming, such as objects, classes, attributes, and of course the way functions work. The official course material is available in a GitHub repository here. This is a public repository. We'll upload everything here, except the assignments. The assignments will be later uploaded today or tomorrow. But the official assignment handling is done through GitHub Classroom. You have already received an invite link for the first assignment. And before you ask any questions, please consult the course material. We try to include everything here. And if you don't find the answer to your questions, then we suggest using the public Slack channels where any of the instructors can answer your questions, or even other students. You are encouraged to help each other as well. There is a large number of you, so we won't be able, actually there are over 100 participants right now, so we won't be able to help everyone one-on-one. It's a much faster way to ask on the public channels. The same goes for this lecture. So I don't see your faces right now. If you have a question, then Slack, you either can interrupt me and ask with audio, or you can ask on Slack, or maybe on the Zoom chat, which will be followed by the other instructors. The format of the course is the following. We'll start with Jupyter notebooks. That's the thing that you see here. This is a Jupyter notebook. We'll also work with standalone Python modules a bit and small packages. So this means Python files, the traditional way of programming. We'll provide skeletons for you that you have to modify, particularly in the first 4 days. You will get most of the code, and you will only have to fill out smaller parts of it. On the last day, you will have a larger project to do on your own. You can use more creativity, so that might be fun. And you may use Google Colab in place of Jupyter notebooks, but the assignments must be submitted via GitHub Classroom using Git, which we already emailed you about. You also need to develop the modules and packages on your local machine because they need to be installable, and you need to test both the installation and the tests, and run the tests on your local machine. But now first let's talk about Jupyter, the application that we are using first. Jupyter is a web application that allows you to create and share documents that mix live code, text, rich text using Markdown, equation, images, visualization, and so on. The notebooks themselves are actually JSON files with the extension IPyNB. So you can look at the source and you will see a JSON file that is somewhat readable for humans, but not intended for humans. They can be converted into various formats. For example, these here are the formats that I could use right now. They can even be converted into slides as well. I will use the default version of notebooks the way you see them right now. It can also render images, tables, graphs, and LaTeX equations, actually. And there are also a lot of extras called using extensions called notebook NB extensions. I'm using free of them. I forgot one here. One is table of contents that you see here on the left side. I highly recommend installing this because it makes navigating in long notebooks much easier. And I'm also using a Vim binding. It's an editor, a keyboard binding that emulates an editor. You don't need to use that. And I'm also using a third one called Black, which is an auto formatter that changes the formatting of code styles according to a standard called Black. You are not required to use that, but it's an easy way of following a code style. Now let's talk about how content is organized here. Content is organized into cells, and there are 3 cell types. So this is a cell, this is also a cell, and we have three types of cells. You can switch between them here. You can use code cells which contain Python code, or actually it can be different languages as well. So you could have, this is a Python notebook, but there are different languages supported. But I think in 99% of the time people use Jupyter for Python. There are also markdown cells, so anywhere where you see text on my screen, they are markdown cells. Markdown is a markup language where you can add basic formatting to using raw text. And there are also raw cells which don't contain markdown. I'm not going to use them here. This is what a markdown cell looks like when you try to edit it. This makes it a header file. This makes it a list. This is a code cell. Code cells look a bit different. So code cells always have a counter here. And if I run a code cell which I just have, this number between the brackets is filled out. And this 1 means that the execution number of this cell is 1. This was run the first time. If I run it again using Control Enter, it changes to 2. Because this was the second cell executed. As you can see, something is displayed here because I printed it, but the way cells work is that the last command's output is displayed. So in the next one, I have 2 instructions, 2 additions, but only the second one is displayed, and it gets an output counter as well. So this is the output of execution 3, 7. The first one is not output. This can include multiple values, of course. We have multiple expressions here, comma separated. This is actually a tuple. We'll cover this more tomorrow. But you can include more of them. This behavior that it outputs last cell is mostly for demonstration purposes. So it's good for debugging and illustrating things, but if you do serious application development, you shouldn't rely on this. The next type of cell is markdown cell. Here I added a bunch of capabilities. I showcased a bunch of capabilities of markdown. So we have bold text, italics text. We even have a table and the LaTeX equation. And the way it looks, the source code looks is this. The LaTeX equation looks scary if you haven't seen one, but you can get used to it if you have to. By the way, it's copied from Wikipedia. Wikipedia also uses LaTeX for equations. If you go to the Edit tab of a Wikipedia page, you can just copy and paste this. I didn't write this, I copied it from Wikipedia. And let's see now how we use Jupyter. So there are two modes, command and edit mode. And when we are in command mode, we can perform non-edit operations on selected cells. What are non-edit operations? Moving the cells around, deleting them, adding new cells, and so on. As opposed to edit mode, when you can edit a single cell, the one being edited is marked green here. So if this is green, then you are editing one cell. If we are in edit mode, then this is going to change to blue. Let's run it, and now it's blue. Here are the ways to change between modes. You can use escape to go from edit mode to command mode, and you can use enter or double click on a cell to go from command mode to edit mode. Running cells can be done in various ways. Of course, there is the run button here, but I think it's much more efficient to use these hotkeys. You can use Control-Enter to run a single cell. You can use Shift-Enter to run one cell and jump to the next one. That's often very convenient. And you can use Alt-Enter to run a cell and insert a new cell below. So I suggest memorizing these, and this will save you a lot of time, and you don't have to keep reaching for your mouse to press and run. And let's see what else Jupyter can do, and then we can get started with the Python language itself. It can also handle user input. We'll use this on today for today's exercises, but we won't really use it on the rest of the days, because asking for user input this way is very good for basic exercises, but not very good for application development. And input is a built-in Python function. That's why it's green. Notice that the syntax highlight is actually helpful for us. It tells us that this is a built-in function. And we input something here, press enter. Until I press enter, there's a star in the execution count. This means that the cell is running. So this actually hangs the execution until I press enter. And when you see that your cells are hanging, then it's often because there is an input somewhere that's waiting to happen. So I try to run the next cell, and now I see 2 stars, and now it's just hanging and not doing anything. And it's because it's waiting for input. And until I give it input, it's not going to run. But now that I enter the input, it runs this cell and then the next one as well, because I already selected run for that. Another one of Jupyter's capabilities is cell magic. We can modify the behavior of a single cell with so-called cell magic commands, such as time. Time will tell us how long a cell the execution of a single cell takes. For example, here I run a for loop through 1 million iterations and do nothing. And that's going to take, it actually varies quite a bit how long it takes. So this is the execution time, but you can see that it's not 0. If I delete a few zeros, then it's going to take much. It actually takes 3 orders of magnitude faster, because now it's microseconds instead of milliseconds. This is often convenient if you have long operations and you want to know how long they take. There is also a better version of timing, something called time it, which will run it a bunch of times. So this will run this cell some number of times. It will print out how many times it's run. Yes, it says that it ran it 100 million times. And the average runtime was 12 nanoseconds with 1.11 nanoseconds standard deviation. And this is now quite stable. So if we run this, if I run it again, hopefully Let me copy and paste it. Hopefully we'll see similar runtime the next time. Of course, it depends on my computer, so how much other resources, how much resources are taken by other programs and so on. But it's somewhat similar within 20%. Here's something slightly longer. And tomorrow I will show you some more interesting stuff with timeit. There's actually a whole bunch of cell magic. I haven't used 90% of that, but here you can find that there is a large number of cell magic operations. These are again good for demonstration and illustration purposes, but not good for serious development. We can also run shell commands here. So this runs the Linux command ls if you run Linux. If you have Windows installed, this might not work and you might have to change it to dir. You can actually run arbitrary command here. So you could use anything here. This will completely step out of Jupyter, and it will run the command on the operating system that you're using. So if I run something here, a command that does not exist, I will just get an error that it does not exist. But it won't halt the execution of a notebook. It won't do anything. It will just fail not silently, but it will fail, and the notebook can move on. Because this is out of the scope of Jupyter, it's not Python. I'm running it on the operating system. I'm emphasizing this because everything else, on the other hand, runs in a shared kernel. So we have this notebook that you see has its own kernel that's running here. You can actually change the kernel here, so you can restart it, or you can interrupt it, or do a few things with the kernel. You can even change it, but I only have Python 3 installed. And the kernel has its own global namespace. So if I define a variable here, set my name to 12, and I add 1, then it's gonna use the previous value, because the global namespace is shared. So whatever this variable is here, it's going to be the same here. And if I increase again, sorry. If I do this, keep doing this, then it's going to increase. But if I reset it again here, it's going to be 13 again. And just as I showed you, actually cells can be run in an arbitrary order. So I can run this first and this second, but it can be changed. And here's something very important about your submissions, is that when we check the submissions, we'll always run the cells in order. So from top to bottom. This means that if you rely on some other order, it might break. And you can make sure that it works the way you expect it by testing it, running kernel and restart and run all. This will clear the kernel, start a new kernel, and run everything from top to bottom. And if there is an exception somewhere, if it fails somewhere, it will stop halfway through. This is very important information, because this means that when we run it, it's also going to fail for us. That it's also going to stop running there and fail. This is very important. So before you submit anything, go kernel, restart, and run all, and make sure that it runs all the way through as you expect it to run. And at this point, I will stop and leave room for questions. I can't read the chat, so if anybody asks questions, then please, I ask the instructors to read the questions from the chat.
We currently don't have more questions. We had one at the beginning that should the students use the TOV address, so the university's address with their GitHub name, but Kinga answered that they should not. They can use their own personal GitHub accounts.
Yes, we'll need some kind of one-to-one assignment between names and GitHub names, but we can take care of that later.
Yeah.
Okay, thank you.
There's another question.
Yes.
Will the practice sessions be recorded too?
No, we can recover the first. We can record the first part, but the way we plan it is that actually most of it will be you will work on your own. So we'll do a few exercises together, and then you should do the rest on your own, particularly the ones that are graded. And you can ask questions, so we'll be available that time. You can ask questions in that 3 hours.
There is also a question regarding the Jupyter. Someone asked that is it enough to use the online Jupyter version? But there is only just this version of Jupyter, so you don't need other like other things installed on your machine, like I don't know, PyCharm or something like that.
You will need PyCharm. So we'll also develop packages. Yeah. For that, you need something else than Jupyter. You can use the online version, yeah, but the submission must be done through GitHub Classroom. So you need to create a local version of the GitHub repository, of your own assignment repository, and you need to submit it through that.
Yes, but you can also open files with Jupyter, so it is.
But we don't recommend that.
Yeah, yes, that's true.
So one goal of this course is to go beyond Jupyter, so that you get a hang of software development in Python as well, because this is more for demonstration. This is not for software development, even though many people use it for software development, especially in data science. But we want to move beyond that. We know it requires a bit more setup and a bit more getting used to, but the reward is also higher, in my opinion. Okay, then let's move on to the Python programming language. First, this will be a little bit of story time, and then we'll talk about the actual language. So here's a very brief history of Python. It's actually not a new language. So it started as a hobby project of Dutch programmer Guido van Rossum in '89. He was also a developer of another language back then, which was his main inspiration. I think the language was called ABC. And but he did this as a hobby project. He started it as a hobby project. And the first version came out in '94. This was around the time that Unicode was introduced. But it was not supported in the first version of Python. We had to wait until Python 2.0 in 2000 until there was Unicode support. This means that it supported all kinds of characters and character sets, scripts, writing systems back in 2000, which was a big thing back then. It also had a cycle detecting garbage collector. It still does, by the way, a reference counting garbage collector. And it became quite popular. And then in 2008, they introduced Python 3.0. So actually, Python 3.0 is not new at all. The proposal started in 2006. I linked the discussion here. And one important thing about Python 3 was that it was backward incompatible with earlier versions. This was a breaking change. It was a very big thing, and it introduced a lot of problems. So many that there are actually a lot of companies that still use Python 2 or have parts of their code base in Python 2 because it's very costly to switch from Python 2 to Python 3. Here, I would draw your attention to use Python 3 and not Python 2, but it's actually very hard to use Python 2 nowadays if you're starting from scratch. So you would have to want that. You would have to seek out for Python 2 if you wanted that. But we are using Python 3 here, and sometimes we might make references to the differences between Python 2 and 3, but they are less and less important nowadays because Python 2 is being phased out. First, they wanted to phase it out in 2015. That was the end of life date, but it had to be postponed 5 years. And I linked some other discussions here on this topic. I recommend reading some of these or looking at them a little bit at least, because they are actually quite entertaining to read, and they are civil discussions. It's a nice way of seeing how language can be developed by the community. And here is the founder himself, Guido, who is the benevolent dictator for life, except that he stepped down in 2018. Let's talk a bit about the community and development. So I said it's very much community driven. Everything regarding the development is open and public. The Python Software Foundation is based in the US, in Delaware. The way they handle new features and bug fixes is through so-called enhancement proposals, or PEPs, Python enhancement proposals, and all the discussion is public. For example, here is the Python enhancement proposal about Python 3, which was submitted by Guido van Rossum in 2006, and it's been finalized since then, thankfully. And this is just I think this is just a short overview, and the actual features are listed in other PEPs. And you can find similar PEPs for basically everything in Python. So we'll introduce some advanced topics in the next days, which were added to Python in the 2000s. And you can find the PEPs, and we'll link them when we can. The community is, of course, very important, and there is a large number of third-party libraries. The standard library itself is also very large, but there are even way more third-party packages, and there is a package index for them called PyPI, Python Package Index. And there is also an installer for these packages, the pip installer. It can install modules from PyPI, or you can use it to install your own module, which we'll do tomorrow and the days after that. There are other installers as well, other package handlers as well, like the one we suggested you use is Anaconda, which includes the Conda package manager, and a bunch of packages come pre-installed with Anaconda. So if you install Anaconda, you will need very little setup after that for this course, at least. Python even has its own terminology for things. I guess because it's the foundation is American, and they like to come up with new phrases. Sorry. For example, if something follows Python's conventions, it's Python-like, it's called Pythonic. If someone is a good Python programmer, it's they are called Pythonist or Pythonista. This is actually not used that much, but Pythonic is. So very often when you search for something on Stack Overflow, for example, you will find that this is the Pythonic way of doing this, and another way is not so Pythonic. There are also a lot of Python memes. I include one here. So from the website XKCD, it makes a joke about how simple to do things in Python because there are so many third-party packages. How do we develop code in Python? Well, one way is notebooks, like the one you see here. So this is basic Jupyter. There is also Jupyter Lab, which you may have seen because the university has a Jupyter Lab installed. This means that you can do this online and you don't have to install anything on your own. There's also Colab, Google Colab, Google's free-to-use online notebook application with GPU access. It's very similar to Jupyter. It looks a bit different, and you can use Jupyter notebooks there. So you could upload this notebook and use it there. It has some limitations, but on the other hand, it has GPU access. So you have limited GPU and TPU access from Google. There are various integrated development environments. We listed two here, VS Code and PyCharm. We'll be using VS Code. At least I think so. I will be using VS Code, but PyCharm is also a good choice. VS Code is free, completely free. It has a Python plugin and so on. PyCharm has a free community edition, and there are command line tools which also have good support for Python, like the Vim editor. Emacs is also a command line editor which has built-in Python support. I will be running some things in Vim. I will be writing some code in Vim, so you can see how it works. And how we format our code, we follow the PEP 8 style guide, and you are also expected to follow that. So this is an older pipe style guide developed by Guido himself in 2001. It specifies everything, how the code should look like, from indentation to line lengths, and how imports should look like, and so on. Class names and function. Actually, class names and function names are perhaps the most important, because it makes your code much more readable if you follow the style. So if you read code that follows this style that you also use, it's much easier to read it than if something is in some idiosyncratic style. And I also use the black auto formatter library, also available as an extension here. That's why the black button. And now let's actually talk about the language itself. So general properties of Python. I'm sure you must know this already, but Python is white space delimited. So instead of curly braces, if you use C, C++, Java, then you've used a bunch of, or C#, you've used a large number of curly braces. In Python, spaces or white spaces do this job for you. And there is no need for the braces or semicolons at the end of the line. So please don't put semicolons at the end of the line. It's actually syntactically correct, but you don't need to use it, and it gives away that someone is a beginner in Python if there are semicolons at the end of the line. So this is what a simple condition looks like. An if-else. If a number is even, we print even. If it's odd, we print odd. And as you can see, the column starts a new block, and now it's indented here. And if we remove the indentation, then it ends the block. We use 4 spaces by default, and please do use that. So yeah, Google Colab uses 2 spaces, but we use 4 spaces here. So all the code will use 4 spaces, and it might mess up your code if you use Google Colab, which uses 2 spaces. Python's type system gets a lot of criticism. It's actually dynamic. So the type checking is performed at runtime as opposed to compile time. So we don't have to declare the type of variable. It's decided when we run the code. For example, here we assign it to the same variable, same reference. First time, it's an integer, because it's an integer number. The value is an integer. The second time it's a floating point number, and the third time it's actually a string. So that's why we have a string here. Now let's see some simple statements. We've already seen the if-else statement. There is also an elif clause. So, for example, here we ask for an input, and if it's a positive number, then we'll print positive. If it's a negative number, we'll print negative. If it's 0, then we print 0. And if it's not a number, then we'll get an error because it can be converted into a number. Let's do 0. We could also do this with one single expression. So there is a ternary conditional operator, but please only use this for very simple expressions. It's similar if you know C, it looks like this in C. And the way it looks in Python is actually different because the order of the operands is different. So this should be the expression evaluated if the condition is met. Otherwise, evaluate expression 2. So this one will compute the absolute value of a number. So it's going to be n if n is not is greater than or equal than 0. Otherwise, it should be minus n. And this is what we get here. The next one, we have to introduce lists a little bit, because we'll talk about lists a lot more in detail tomorrow. But for the exercises, we need a basic sequence types. So let's see how lists look like. So lists are, an empty list can be defined with square brackets, or you could say L is a list, whichever you prefer. The basic operation for adding to lists is append, which will add an element at the end. And let's see how it looks like. We first take the length of the list, it's 3, and the elements are 2, 2, and the string foo. Here I'm demonstrating multiple things. First of all, lists can contain the same element multiple times. Lists are ordered. So there is a first element, there is a last element, and you can go through the elements in order. And thirdly, they can have mixed types. So the elements can be of any type. And here we mix integers and strings. Generally, this is not a good idea. So it's much clearer. It's a better design if you have a single type, or maybe 2 types if you absolutely need to. Like you could mix 2 numerical types like integers and floating points. But it's a cold smell if a list looks like this, that you have strings and integers and other lists as elements and so on. It's very hard to read your code. But Python will not stop you from this. This is, by the way, true in general. So Python will not stop you from writing bad code. It's on you that you have to be disciplined and you have to think about the design, which you can. So there is a big difference between Python code and Python code. When you start reading other people's code, you will notice that some code is much better designed and easier to read than other code. But let's move on with lists. We need to know basic iteration. Here is how you go through a list. So a for loop, a basic for loop looks like this. So here's we define the list on the fly here, and then we take an iterating variable, and that goes through the elements of the list. We often need the index of the elements, so we need to know where we are at, and Python has a built-in function for that called enumerate, which will go through the elements and the index. And the first one, so we're getting actually two variables in each iteration, an index and the current element. And this is what they look like. The elements are indexed from zero. But the length of the list is 2. So if a length of a list is n, then the last element is n minus 1. And the first element is 0, index 0. There's also another frequently used built-in function called range, which will iterate through integers. This is mainly used to do something a number of repeated times. For example, here we are printing the numbers, but very often we just want to do something 5 times. Perhaps the same thing. So if we want to print something 5 times, please do not repeat this line 5 times. Instead, use a for loop with range 5 that will do it 5 times. And in this example, I'm using underscore as a variable name. This is a convention. So underscore is a valid variable name. We could use underscore. We could actually use underscore anything here, except anything. Perhaps stick to the English characters, but I think you can use even accented characters, which I don't recommend. But what we do here with a single underscore is that we want to let the reader know that we don't care about this variable. We are not going to be using it. We just need something to iterate through the range of 5 values. And that's but we discard the value. We won't use it. This is just a convention, so it's actually available. So you could say it's here. You could use it because it's a valid variable name, but it's a convention that we don't use it. You will see a lot of such conventions in Python, and it's better to stick with them. Okay, another thing about the range is that it started from 0. 0 was the first element, and the last one was actually 4 and not 5. This is very important. The ranges in Python are open from the right side, closed from the left side and open from the right side. So this means that the last one will not be included. And you're asking what is the left side here? Well, the left side is by default 0, but we could specify the start here. So here is another example where we pass two parameters to range. And the first one is going to be the start. The second one is going to be the last one, going to be the right side. But the right side is not included. So it's only 2, 3, and 4. This is a design choice, a deliberate design choice in Python. There are many upsides to this. For example, the fact that if you subtract the 2, so from 5 minus 2, you will get 3. This means that there are exactly 3 elements in this range. This doesn't look very important right now, but when we do something like this we have a variable here. For example, window size, not I. Let's say start. Then we can know that this thing is going to be, the length of this thing is going to be window size. So we are starting from here, from 4. And there are 5 elements because 5 is the window size. Range also has a third parameter, the step size. Here's an example. So if I'm going from 0 to 10, and here's the step size. And now we are not including every element, but every second element. We can also use negative values here. This will go in the opposite direction. So from -3, we are going to 0, but we are stepping -1 each time. And it turns out that this range is empty. So there's no error here, no output, because the range itself is empty. And the for loop never got to this point. If you want to go the other way, then the start should be 0 and we should go to -3, and then we get our 3 elements. An important thing is that range only accepts integers for any of the all 3 parameters must be integers. And I get an error if I try to use something other than integers. For example, here I wanted a scale from 0 to 1 with 0.1 steps. This is something you would frequently want if you, for example, want to plot something. But we can't do this with range. But do not worry. The NumPy module has a built-in function for that called arange. This is basically a much smarter version of range. It accepts floating points as well. And here are our beautiful scale that I could use as the x-axis for my plot. For example, arange can use any integers, any kind of floating point numbers. But otherwise works the same way. So it will be open from the right side. As you can see, 1 is not included. Open from the right side, close from the left side. So we are starting from 0. Do we have any questions at this point? No questions, then let's go on. Python has both break and continue. Break will allow early exit from a loop. So here we have a for loop with a break. It doesn't make much sense. It's just an example, because if we are breaking, if we know exactly when to break out, then we should have just run it until 5. But break is often used when you have when you're working on other data, like you're working on a data structure, and based on the contents of the data structure, you stop at some point. Similarly, there is continue, which will not break the for loop, but rather it will just skip the rest of the execution of the inner block and go to the next one. So, for example, here is this for loop. We are going from 0 to 10, and if it's divisible by 2, if its modulo 2 is 0, then we continue. This means that that we skip the even numbers, or if we see an even number, then we won't print it. We won't get to print. But this should be familiar from other languages. They work exactly the same way. But the next one I'm going to show is something that's not widely used in other languages. Neither is it widely used in Python, but it's there. So if you see it, don't be surprised. For loops have an else clause as well. What does it mean? Else clause mean is that if the for loop finishes successfully, so if there was no break, then it will run the else clause. So let's look at this in more detail. Again, if we see an even number, then we are going to break out of the for loop. Let's see the numbers here. All of them are odd numbers. Let's add an even number. And now the else part is never run because we break out of the for loop. So we're either breaking out, or if it never happens, then we run the else part. It's there in Python. I've seen this maybe once in live code. I think most Python developers are not familiar with it, and it's not widely used. But if you see it, then you should know that this is what it does. There's another kind of loop in Python called while. While we run until a condition is true. So until this condition is true, this will run. And when it's no longer true, then we end the while. And as you can see, that that after the while loop, the value of I is 5. So this means that it was increased one last time, but this time when this increment happened, then this condition was no longer true. So we break out of the loop. And you may know do while from other languages. There is no equivalent of that in Python. Okay, any questions at this point? No questions, then let's move on to functions. And functions can be defined using the def keyword. And this is a simple function. It just prints something. Functions are much more interesting when they have arguments. And there are two types of arguments in Python. There are positional arguments, and there are named or keyword arguments. And when we pass the arguments, we can do them either way. We can either pass by position or we can pass by their name. And this will be a very useful and flexible behavior, as I will show you later. Let's see this. This function has now 3 arguments and it just prints the arguments. The first time we call it, we pass all 3 in order, but we specify the name of the third one. It's not necessary, so I could remove this. And it would result in the same thing. But we can also pass it via name. In the second example, I pass both argument 2 and 3 with names. And now I can actually change their order. So now the order doesn't matter because Python can work it out which one is which, since I specifically said that this is argument 3 and this is argument 2. And it would just work out the way. And as you can see, argument 2 was 2 and argument 3 is the string. If I don't do this, if I don't use names, it will also work, but it changes the argument. So now argument 2 is this one and argument 3 is that one. Because they are all passed as positional arguments. And now the only way Python can work out which one is which is that look that, okay, this is the first one because it's in the first place, this is the second one, it's in the second place, and this is the third one. There is one limit to this mechanism of passing these parameters, namely is that it has positional arguments must be before keyword arguments. So this one will give me an error. And it says exactly what's the problem. By the way, you should be familiar with reading these errors. So most of the time, the errors are very helpful. So it says positional argument follows keyword argument, which is exactly a problem. And I even get a small arrow-like thing here that tells me that this is the problem. This is where the syntactic parser told me that this is incorrect. How would we fix this? There are 2 ways of fixing this. Either move the positional one here, or specify its name. Both of them will fix this, because if I specify its name, then it's clear what is what. But this way, it's an error. And very similarly to this argument passing mechanism, we can also name the arguments in the function. So we can have keyword arguments here with defaults. So this means that argument 3 will default to 3. And if I don't pass it along when I call the function, then it will use 3. It will use the default value. If I pass along something, then it will use whatever I passed along. And again, one limitation is that the arguments with defaults must follow all non-default arguments. And if I try to do this, then I get a syntax error. Non-default argument follows default argument. This time, this is not super helpful because the error is actually here. Let's do this. And again, here are some more examples. So we can specify the arguments in any order. And here another example with multiple defaults. So we have now argument 2 and 3 are both default arguments. This means that we actually have very great flexibility of how we do this, how we use this function. So here in the first call, we only pass along the first parameter, so the defaults are used for the second and the third. In the next one, we use the default for the third, and in the last one, we use the default for the second one, but not the third one. So as you can see, this is the answer here. This is the output here. So the second one is default, but the third one is not default. And this is possible because we can pass along via keywords. And why am I stressing this so much? It's because this is how many libraries are designed in Python. Actually, maybe all of them. So many functions in libraries that you're going to use have a very large number of parameters, but you usually don't specify most of them. For example, here is the pandas library, which you may have heard of. Pandas is a tabular data manipulation library, very widely used in data science. So we'll definitely hear more about it later on. And this is read CSV function, which can read the CSV file, a common format for input data in data science. And here is the function signature. So these are the parameters. Actually, I copied this a long time ago, so it may have changed a bit since then. But as you can see, there is only a single positional argument, and this one is of course, this one is mandatory. So you have to specify, if you are reading a CSV file, you have to specify what file you are reading, so where you are reading from. But anything else is optional, and it has same defaults. So most of the time the defaults are good for you, but sometimes you want to override some of these. And using the keyword passing keyword passing mechanism, you can pick any of these, any one of these. And in general, at most you will see 4 or 5 parameters overridden out of this. What is it, 25 maybe? Okay, any questions? I know this was a bit heavier topic than the previous ones.
Yeah, there is a question in chat, I think, concerning function calls. Position is higher priority than the name of argument?
I wouldn't say, I don't think higher priority is the best term for this. They are mandatory. So if it's positional and it doesn't have a default, it's mandatory. So if I use pandas here, I must provide a file path or buffer. So the file name I'm typically the file name I'm reading from. I hope that I answered the question.
Another question. So there is no function overloading like in C++, C# or Java?
Yes, very good question. No, there is no function overloading. Function overloading would mean that you could have multiple versions of the same function, the same name, but the types are different. The argument types are different. And there's no overloading. First of all, there are no types here. So we do not specify the types of the arguments. And second of all, there is no overloading, but in place of that, we get this this highly flexible mechanism for using functions with different parameters. And since there are no types here, so for example, this parameter here, it could be a string or it could be a buffer, like an already open file or something like that. So internally, most likely the function does reflection. So if we check the type internally and do different behavior based on the type of the parameter passed along. But for the person who asked if there is no function overloading, there is none, but there is operator overloading. And you will see that, I think, on day 3, Kinga will show you some examples. It's not widely used, but there is operator overloading. Okay, then let's move on. The return statement. The return statement is not super interesting, not as interesting as parameters. We can return mixed types. So as you can see in the function definition, there is no return type as well. So I didn't start it with integer. So this means that the same function, depending on its behavior, can return different types. And here are some examples. So here I have a function that takes something that it handles it as a number, and if it's negative, it returns the string negative. If it's between 0 and 10, then it will return positive and the number. So here we have multiple return values. And if it's neither, then it will return none. So the first one, negative, it returns a string. In the second one, we return a tuple, so a pair of values, positive, and the number itself. And I printed the type of it, it's a tuple. We'll talk about it tomorrow. And in the third example, we never actually have a return statement here, because this is false and this is false as well. So we get to the end of the function, but if there is no return at the end of the function, it will return none. So Python has a designated none object. This is a singleton object, and there is only one of it, and it's used by default as a default return value. I also wrote 2 versions, so you could have this or this, and it will do the same thing. So if we are explicit about it, then here it's also none. If you have an empty return statement, that will also return none. So return is very flexible. Again, it will not stop you from writing bad code, but you should be disciplined, and you shouldn't mix return types. So it's actually very hard to read the code if you have mixed types like this. And it's considered a code smell if function looks like this, as it returns a number one time, a string another time. So we should design our code in a way that we only return one type of object. Actually, one type of object and none. So the union of these is accepted. That's considered even Pythonic. So for example, if you do some data processing, or you want to find something in the data structure and you don't find it, you may return none. That's okay. And with this, I actually finished the first part that I wanted to say. I linked some useful resources. First of all, the documentation itself is very good. So I recommend reading this. By the way, here is a version chooser here. So, but it won't really matter. So don't do Python 2.7. But otherwise, if you go later than 3.6, it doesn't really matter. There are a few things that we use that are the later Python. But if you installed Anaconda now, it should be, I think it's 3.9. It's at version 3.9 right now. And this is pretty good. It looks daunting at first, but if you go if you go inside, then it's not bad. It has a lot of examples and so on. The second one, I like. It depends on the person, but I like watching videos, and there's a large number of Python conferences. It has English and non-English versions, but most of them are English. And the biggest one is, of course, PyCon US. And it's a yearly conference, and they make the videos online. So you can go here and you can go on their YouTube channels, and I think there's a search interface somewhere. But anyway, there are hundreds of excellent videos for reading them. You can see that for this year's PyCon, there are over 100 videos, and they are at every level. So you will find 3-hour tutorials for complete beginners, and you will find highly advanced topics from the core developers of Python, which can also be very entertaining. So if you like watching videos, they are usually 20-minute long, the presentations, and there are some longer ones, and the tutorials are maybe overly long. But if you like watching videos, I highly recommend this as a resource. There are also YouTube channels. I linked my 2 favorite ones. mCoding, an American YouTuber who does short videos on Python and C++, and he covers many of the new features. He covers small peculiarities of Python. He has videos on stuff like newbie habits and so on. And the other one I linked here is Aryan Codes. It's his name, that's why it's Aryan Codes. In case anyone is wondering, he's a Dutch YouTuber, but his videos are in English, and he is also very good. He often goes from a traditional software development background. So if you learn C, C++ in traditional university courses, then his style of teaching will be very familiar. And there are also subreddits. r/Python is a huge subreddit with high traffic, with 1 million subscribers. There's also Learn Python, and the machine learning subreddit, which is not strictly Python, but you will find some Python related topics. And of course, I guess most of you are interested in data science here, so machine learning is something that you should look at. And you could continue this list of useful resources forever, because fortunately nowadays it's very easy to find good resources. And if you find something useful, then feel free to send it to the Slack channel as well. And I actually finished a bit early with today's lecture. So we have 2 choices now. We can stop now and meet again at the afternoon session, or I can get started with lecture 2, which is longer than lecture 1. So I think lecture 2, I vote for starting now, but I'm interested in your opinion. I can do a poll right now. What happened? I'm seeing a blank screen. Do you also see a blank screen?
Yes, we see a blank screen for you.
That is weird. Okay, the problem is that I don't want to kill off Zoom. This is definitely something Zoom is doing to me. I'm trying to clip stop sharing. It's somewhere here. Ah, yes. Okay, let me share again. And now it's okay, right?
Yes.
Okay, do we have some consensus of what we should do? I saw chat messages on Zoom, but I can't open them right now because of the screen sharing.
No, it was actually a question on the exercises, so no preferences given yet.
Okay, then what is the question?
The question is, it was already answered by Kinga, but the question was, should we include exception handling in the exercises?
Yeah, we moved the exception handling to day 3 because if you know about classes that helps with exception handling, but if you want to, you can, of course. But you will see the exercises are very the first 2 days are very much built in a test framework. So you will have assert statements everywhere. You will have public tests, and you only have to write the functions. But in general, so the Pythonic way is that you don't have to check for everything. So you expect the philosophy of Python is that the developers are adults, and if you have a function named named well, for example, it's some function that works on numbers, and somebody passes along strings, it's their problem. Until then, I want to show you the Zen of Python. Okay, then, so there's not much time left, so we can continue in the afternoon. Now, I won't start lecture 2. We'll go a bit faster tomorrow because there is more material to cover. Today was an introduction. If you found it too slow, then don't worry. Tomorrow will be faster, and the exercises will be more difficult. But we try to include some advanced exercises even today. Okay, then if there are no more questions, then thank you for your attention. Oh,
there is one actually, sorry.
Okay.
The question was, there are some tasks without points. Are they optional?
About what?
There are some tasks without points. Are they optional?
Yes, we will not grade them. Only the tasks with points are graded, but we highly recommend doing them.
I'm sorry, a stupid question. Maybe where are the tasks already published?
Yes, we sent a GitHub invite link, so it's a GitHub Classroom assignment, and the link was sent on Slack, and I think it's also posted on tuw. I hope I'm pronouncing it right.
Yeah, the
I
link
will
is on GitHub for tuw.
Yeah, I will stop sharing now, and I will stop recording. How do I stop recording?